Carbohydrate metabolism, and in lecture 9 in the last two classes we studied glycolysis and gluconeogenesis. So glycolysis was um, catabolic reaction, and gluconeogenesis is an anabolic reaction. So in the glycolysis we studied breakdown of glucose to pyruvate, and gluconeogenesis we studied the formation of glucose from non-carbohydrate source. And in this class we will study glycogenesis. So there are two terms, one is glycogenesis, another is glycogenolysis. So glycogenesis means the synthesis of glycogen from glucose, and this is an anabolic reaction, and glycogenolysis means breakdown of glycogen to glucose. This is an catabolic reaction. So before studying glycogenesis, we need to know what is glycosidic bond and how glycosidic bond is formed. Although we have studied this one in last class, but today we can repeat it once again. So when a hydroxyl group of one sugar react with hydroxyl group of anomeric carbon of another sugar. When hydroxyl group of one sugar react with the anomeric carbon of another sugar, releasing one molecule of water, and alpha 1,4 linkage is formed. This is the glycosidic bond. So why alpha? Because it will depends on the anomeric carbon containing sugar. If the anomeric carbon is in alpha form, the bond will be alpha form. If the anomeric carbon is in beta form, the bond will be beta form. So here you can see the anomeric carbon, the hydroxyl group in the bottom side. So this is in alpha form, so the bond will be alpha form. If the hydroxyl group will at upper side, the glucose will be at beta form, so the bond will be beta form. Okay, so and here the number 1 carbon and here the number 4 carbon has been linked, so that the bond is alpha 1,4 linkage. So I repeat, when a hydroxyl group of one sugar react with anomeric carbon of another sugar and release one molecule of water, they form glycosidic bond. So glycogen is a polymer of glucose containing 120,000 glucose residue and is a primary carbohydrate storage form in animals. So glycogen is stored in muscles and liver as large particles together with enzymes that metabolize glycogen as well as regulatory enzyme. The polymer is composed of units of glucose linked alpha 1,4 with branches occurring alpha 1,6 approximately every 8 to 12 residues, and the end of the molecule containing a free carbon number 1 on glucose is called reducing end, and the other ends are all called non-reducing end. So this is non-reducing end and this is reducing end. So we studied the definition of reducing sugar. Similarly, in a glycogen, the right side or the right terminal has a free hydroxyl group at the anomeric carbon, so that it is the reducing end, and the left terminal side it does not contain any free hydroxyl group at anomeric carbon, so this is called non-reducing end. Okay, related polymers of glycogen in plants called starch and amylopectin. Okay, so starch contains two types of glucose polymer. One is amylose, another is amylopectin, and glycogen is similar in structure with amylopectin of starch, and cellulose has no branching, although it is different from amylose. So starch is moderately branching, but glycogen is highly branched and cellulose are not branched. So biosynthesis of glucose, starch and sucrose depends on three important depends on three important statistics. So the principal storage form of glucose or glycogen in vertebrates and starch in plants. So in vertebrates, glucose itself is generally transported in the blood, but in transported form is sucrose but the transported form in plants is sucrose or its glycosylate derivatives. So the UDP glucose is substrate for glycogen synthesis, and ADP glucose is substrate for synthesis of starch in plant, and also UDP glucose is substrate for synthesis of sucrose in plants. So in glycogen synthesis, glycogenesis is the process of glycogen synthesis in which glucose molecules are added to chain of glycogen for storage. So there are two types of mechanism of glycogen synthesis. The first one, elongation of pre-formed glycogen by addition of sugar molecules, like addition of glucose molecule, and secondly, the production of glycogen de novo. Okay, so the first step is production of UDP glucose. So glycogen synthesis takes place in animal tissues, but especially prominent in liver and skeletal muscle. The starting point is synthesis of glucose 6-phosphate from glucose as like the first step of glycolysis by hexokinase. That means existed glucose will be converted to glucose 6-phosphate by hexokinase 1. Then glucose 6-phosphate is converted to glucose 1-phosphate by phosphoglucomutase, and then glucose 1-phosphate will be converted to UDP glucose by UDP glucose pyrophosphorylase. Then this UDP glucose will be working as a carrier of glucose, and it will donate the glucose in glycogen synthesis. The last step is the UDP glucose donates glucose residue to the non-reducing end of glycogen in the reaction catalyzed by glycogen synthesis. Let's say this is a glycogen chain, and this is the non-reducing part with n residues of glucose, and definitely n should be greater than 4. And then if there is a p-form glycogen chain, glycogen synthase enzyme can only be able to add glucose on it, otherwise glycogen synthase enzyme will not working. So it is very important for glycogen synthase function is a presence of pre-existing glycogen. So what happened there, the UDP glucose will donate one glucose molecules to the non-reducing end of glycogen chain, that means preformed glycogen chain, and here you can see glycogen has been elongated with one glucose residue. So this is how the preformed glycogen chain is elongated by glycogen synthase. And what about the branching point? So glycogen synthase cannot make alpha 1,6 bond at the branch point of glycogen. So these are formed by glycogen branching enzyme called amylo alpha 1,4 to alpha 1,6 glycosylase, or transglycosylase, or glycosyl 4 to 6 transfer. So look at here, this is the linear chain of glycogen. So after 1 2 3 4, after 4 glucose residues, and the glycogen glycogen branching enzyme will cut it down here and will transfer this part to there, making alpha 1,6 linkage here. This is how glycogen form branching here by branching enzyme. Okay, so that was the synthesis of glycogen or glycogenesis. So how about the glycogenolysis? Oh, okay, we will study glycogenolysis later. Before that, the second part of glycogen synthesis we will study here now. So in the beginning of glycogenesis, I say there are two methods of synthesis of glycogen. The first one is elongation of a preformed glycogen chain by addition of glucose, and another is if there is no glycogen in your body, so how the glycogen synthesis will start de novo. Okay, so glycogen synthase enzyme has a limitation. It cannot initiate new glycogen chain de novo. So it requires a primer, usually a preformed alpha 1,4 polyglucose chain or branch having at least 8 glucose residue. Okay, so how is a new glycogen molecule initiated? There is a protein called glycogenin, this working as a primer on which new chain are assembled and it is working as an enzyme that catalyzes their assembly. So the first step in the synthesis of a new glycogen molecule is the transfer of a glucose residue from UDP glucose to the hydroxyl group of tyrosine 194 of glycogenin, catalyzed by the protein's intrinsic glycosyl transferase activity. So as we know, glycogen has two functions. One is primer and another is enzyme. So it itself has glycosyl transferase activity. Okay, now we can see glycogen has been attached with one glucose, and this nascent chain will be extended by sequential addition of 7 more glucose residue from UDP glucose, and the reactions are catalyzed by the chain extending activity of the glycogenin. Okay, so this will repeat 6 times until 7 glucose molecules attached. So what about the biosynthesis of starch? In most plants, starch is the main storage form, but in a few plants such as sugar beet and sugar cane, sucrose is the primary storage form. Okay, starch like glycogen is a higher molecular weight polymer of D-glucose in alpha 1,4 linkage, and it is synthesized in chloroplast for temporary storage, and for long-term storage it is synthesized in amyloplast. So ADP glucose is the substrate for starch synthesis, and starch synthesis and a branching enzyme introduce a alpha 1,4 and alpha 1,6 linkage in amylose and amylopectin respectively. So this is the overall reaction. So starch having glucose 1-phosphate, starch elongated by 1 glucose, and ADP is used here. So what about the biosynthesis of sucrose? So sucrose biosynthesis start from we know sucrose is glucose and fructose. So it starts or sucrose synthesis begins when UDP glucose donates its glucose molecule fructose 6-phosphate and catalyzed by fructose 6-phosphate synthase enzyme and produces sucrose 6-phosphate, and then the sucrose 6-phosphate phosphatase trim the phosphate group, releasing sucrose containing glucose and fructose. So during active photosynthesis in bright light, a plant leaf produces more carbohydrate than it needs, and the excess is converted to sucrose and transported to other part of the plant to be used as a fuel stored. Sucrose is synthesized in cytosol, beginning with dihydroxyacetone phosphate and glyceraldehyde 3-phosphate exported from chloroplast after condensation of 2-triose phosphate to form fructose 1,6-bisphosphate catalyzed by aldolase enzyme and hydrolysis of fructose 1,6-bisphosphate L to produce fructose 6-phosphate. So glyceraldehyde 3-phosphate and dihydroxyacetone phosphate contains to form fructose 1,6-bisphosphate. That reaction is catalyzed by aldolase, and then fructose 1,6-bisphosphate hydrolysis produce fructose 6-phosphate, and sucrose 6-phosphate synthase then catalyze the reaction of glucose UDP glucose and fructose 6-phosphate to form sucrose 6-phosphate. Then finally sucrose 6-phosphate phosphatase remove the phosphate group, making sucrose available for export to other tissues. So now we will study glycogenolysis. So glycogenolysis, that is the study of breakdown of glycogen. So glycogenesis is the breakdown of glycogen producing glucose 6-phosphate and glycogen 1. Okay, so this is glycogen having n times of glucose, and where glycogen phosphorylase remove 1 glucose from the non-reducing end, producing glucose 1-phosphate, and glycogen shortened by 1 residue glucose, let's say n-1. So then glucose 1-phosphate is converted to glucose 6-phosphate by phosphoglucomutase, and then glucose 6-phosphate is converted to glucose by glucose 6-phosphatase. Then this glucose will deliver to the blood to supply glucose in case of our body's need. So that is the removal of glucose by glycogen phosphorylase in linear chain. So what about the branch? So here is the summary of the glycogenolysis. So here this is the non-reducing end and this is the branching point. So the glycogen phosphorylase will trim glucose one at a time, and then it stops working when it says there is remaining 4 glucose before the branching point, and then it stops here working, it stop working here, and then the transfers activity of debranching enzyme will transfer this 3 glucose molecule here, making this one, and glycoside's activity of debranching enzyme will trim the glucose here and remaining the linear and making it a linear form, and then glycogen phosphorylase again start to working here and remove glucose at a time. So regulation of carbohydrate metabolism in glycolysis in muscle and liver tissues, there are 4 enzymes that plays a regulatory role. One is glycogen phosphorylase, the first enzyme of glycogen breakdown, and the hexokinase, the phosphofructokinase, and pyruvate kinase. Those 3 are the enzyme of glycolysis. Okay, so those all 4 enzymes are involved in phosphorylation or dephosphorylation of the carbohydrate intermediates. Okay. So hormonal regulation of glycogen metabolism. So there are 3 hormones that are involved in hormonal regulation of glycogen metabolism. The first one is insulin, and second glucagon, third epinephrine. Insulin is secreted by pancreas under high blood glucose level, and it stimulates glycogen synthesis in liver and increase glucose transport into muscle and adipose tissues for breakdown. And glucagon secreted by pancreas in response to low blood glucose, and which stimulates glycogen breakdown, acts primarily in the liver to elevate the blood glucose level. Epinephrine looks like similar with the glucagon that secreted by adrenal gland and stimulates glycogen breakdown and increased rate of glycolysis in muscle and release of glucose from liver. So that's all from the carbohydrate metabolism today.